Okay, the third major topic in this section is probabilities as fractions, decimals, and percents. I know, I can hear some of you shuddering already. We don't like fractions, decimals, and percents, but we can't avoid them here. Okay, so a probability can be any fraction from 0 to 1 inclusive. That's the basic rule here for what probabilities can and cannot be. Since the only probabilities that we can actually calculate are based on this formula, they are inherently fractions. That means that they cannot be irrational numbers. So you might remember from 7th grade algebra or pre-algebra or whatnot that numbers can be either rational or irrational. Rational means fractions. Irrational numbers are not fractions. The only irrational numbers that are tested in this class are square roots. So basically, if you see a question that says, can a probability be the square root of 3/4? No, it can't. It can't be a square root. It has to be a fraction. Okay, so every fraction can be converted to a decimal or a percent. Decimals are generally preferred in higher math. So we see a lot of percents when we're growing up in grades K through 12, but higher mathematicians rarely use them. Decimals are a little bit more straightforward for calculating with. So just so you're aware. But theoretically, you should be able to convert a fraction into either a decimal or a percent. So that's the form that a probability can take. As far as the size of the probability, this is the mathematical way of writing the correct range of values. The probability of x has to be between 0 and 1, and these little or equal to bars here mean that the probability can be 0 or 1. That's what we mean by the word inclusive. So a probability ranges on a spectrum from 0 to 1, basically, ranging from the impossible to the certain. So let's take a look at what I'm calling the probability spectrum, and then we'll do a couple of examples with that. So this is the first page of my illustrations and examples handout. I call this the probability spectrum. And I've drawn this spectrum vertically because remember, we normally think about probability as being on the vertical axis. So I want to get accustomed to seeing it like that. So a probability can range from 0 down here all the way up to 1. It can't be below 0, so you'll never see a negative probability. And it can't be above 1, so you'll never see probabilities like 1.1 or 2. But it can be any fraction in between. The halfway point, the probability of 0.5 or a half, means just as likely to happen as not. So a probability of 0 means that something is impossible. A probability of 1 that means it's absolutely certain to happen. It's a foregone conclusion. And the halfway point means, it's just as likely to happen as not to happen. So in this orange zone here, these are probabilities that are less likely than not. And if those probabilities get very low, we get into a range where we would actually be surprised if this event happened. It's a rare event. And we're going to be introducing ourselves to the word significant pretty soon as attached to this. How do we define a rare event? Sometimes it's just a subjective feeling, but in math class, we prefer to quantify things. So the default is 5%. Unless a problem states otherwise, which sometimes they do. Sometimes we'll be given a significance level of 1% or 10%. But it's always going to be in the ballpark of 5%. And if a significance level is not stated at all, the rule is to use 5% as a default. 5% meaning 0.05 as a decimal. So if a probability is less than 5%, that means we'd be surprised if it happened. What's the probability that you will guess my birthday correctly? It's only 1 out of 365. So that's less than 5%, isn't it? I'd be surprised if you could do it. And then when we get up above probabilities of 50%, we get into the yellow zone where events are more likely to happen than not. If you pick a random day of the week, what's the probability that you'll have to go to work on that day? It's probably more than half. Most of us work 5 days and take 2 days off, so it's probably more likely than not that you'll have to work that day. And then as a mirror image, on the upper end of the scale here, if we get up above 95%, we're getting into events where we'd be surprised if it didn't happen. All right, so that's what I mean by that probability spectrum. Let's take a look at numbers 5 and 6 on this worksheet. Yeah, all right, so special probabilities is what I'm calling the topic here. Number 5. In number 5, we are going to choose from among the 20th century United States presidents. So that is a closed list of people who are known. They range from President McKinley to President Clinton, so we know exactly who they are. If we choose any of the 20th century U.S. presidents, find the probability that that president will have been a man. Well, I think you probably know from history class that so far, all of the U.S. presidents have been men. And that was certainly true in the 20th century. So that is a certain conclusion. The probability will be 1 or 100%. What is the probability that a 20th century president chosen at random will be a woman? Well, unfortunately, none of them were women, so that probability would be 0. Okay, so that's what those special endpoints mean. A probability can be 1 if it's foregone, or 0 if it's impossible. Now, of course, I've restricted this to 20th century, but if I change the question and said 21st century or future, then of course we wouldn't know anymore. And then these probabilities would be entirely subjective guesses, because I think it's pretty likely that a president will be female pretty soon. You might disagree. That's why it's called the subjective probability. Number 6, which ones could or could not be probabilities? So choices A, B, C, D, and E. Some of these numbers are valid probabilities and some are not. Choice A is the fraction 1/4. I'm trying to zoom in here. Choice B is negative 0.65. Choice C is 150%. Choice D is the square root of 7 over 3. And choice E is 0.08156. It's a pretty easy question. What do you think? Which ones could be probabilities? A, 1/4 is a fraction between 0 and 1. That's fine. And choice E is a decimal between 0 and 1. So choices A and E are the ones that could be probabilities. There's something wrong with all the others. Choice B is negative. You can't have a negative probability. Choice C is larger than 1. Any percentage more than 100% is larger than 1, and that could not be a probability. And choice D is an irrational number. Even though it's in fractional form, the numerator itself is irrational, so that makes the whole thing irrational. The square root of 7 could never be part of a probability.